Good morning, everybody. Good morning, everybody. Let us discuss Kirchhoff's voltage rule. It states that the sum of potential differences across the elements in a closed loop is equal to 0. In figure 1, there are three closed loops L1, L2 and L3 respectively. The direction of closed loop is chosen along a clockwise direction. However, it can be chosen along anti-clockwise direction also. So choosing the direction is arbitrary. Applying Kirchhoff's voltage rule for loop L1, V1 minus I1 R1 equal to 0, where I1 current is flowing across the resistor R1. At loop L2, minus I3 R3 minus I2 R2 plus V2 plus I1 R1 is equal to 0, where I2 current is flowing across R2, I3 current is flowing across R3. I shall explain the details of sign convention of voltages. At L3 loop, V3 minus I4 R4 plus I2 R2 equal to 0, where I4 current is flowing across R4. Let us see the sign convention for the potential difference across battery. When current flows from positive terminal to negative terminal, the potential decreases. So, it is regarded as minus V. If current flows from low potential to high potential, that is, from negative terminal to positive terminal, the potential increases. Hence, it is regarded as plus V. Similarly, when current flows across resistor, there is potential loss, so it is plus IR. If we consider the loop direction opposite to current direction, then it shows potential gain. So, you see in loop L1, I1 R1 is negative, but for loop L2, I1 R1 is positive. Since for loop L2, we consider the direction of loop is opposite to the direction of current. Hence, there is potential gain, that is plus I1 R1. At loop L2, I2 R2 is negative, but at loop L3, I2 R2 is positive, since as per the direction considered for loop L3, which is opposite to the direction of current I2. So it is clear that the choice of direction of current is arbitrary. The choice of loop direction is also arbitrary. It may be clockwise or anti-clockwise as per the convenience. Let us illustrate Kirchhoff's voltage rule to find current at various branches of the given circuit as shown in figure 2. Here I assign anti-clockwise direction of loop L1 and L2. I1 current is flowing from negative terminal to positive terminal of battery, so it shows the potential increase, that is plus V. At loop L1, direction is along the direction of the current through the resistance R1. So there is potential loss, that is minus I1 R1. Loop L1 direction is along the direction of current, though through R2 and R3. So there is potential drop through R2, that is minus I2 R2. The potential drop through R3, that is minus I3 R3. Hence, according to Kirchhoff's voltage rule, V1 minus I1 R1 minus I1 R2 minus I3 R3 is equal to 0. The values of the voltage V1, which is assigned as 50 volt. So putting all the values of voltage and resistances as shown in figure 2, the above equation becomes 50 minus 5I1 minus 6I1 minus 10I3 is equal to 0, or 50 minus 11I1 minus 10I3 is equal to 0, or 50 equal to 11I1 plus 10I3. For loop L2, the current I2 is flowing from positive to negative terminal. Then the V2 of battery, that is from high potential to low potential. So it shows potential decrease. Hence it is regarded as minus V2. The loop direction is along the direction of the current through the resistor R4. So there is potential drop minus I2 R4. The loop direction is opposite to the direction of current through R3. So it shows potential increase through this resistor having resistance R3. Hence it is regarded as plus I3 R3. So the Kirchhoff's voltage rule becomes minus V2 minus I2 R4 plus I3 R3 is equal to 0, or minus 20 minus 4I2 plus 10I3 is equal to 0. We put the values of voltage and the resistances for this given loop L2. So the simplified equation becomes 10I3 minus 4I2 is equal to 20. As per current rule, the sum of the current at any node is equal to 0. So at B node point, I2 plus I3 minus I1 is equal to 0. Now we can substitute the value of I3 in the above equation and we get the equation with the two variables I1 and I2 respectively. So by solving these two equations with two variables I1 and I2, we can get the value of the current I1 is 2.58 ampere, and putting this value of I1, again we can solve for the current I2, which can be as I2 equal to 0.41 ampere. Now putting the value of I1 and I2 in the last equation, we get the value of the current I3, which is 2.17 ampere. So we can solve the value of the current at various branches of the circuit. Here we assign the direction of the current as I have told earlier, which is quite arbitrary. You may choose the direction, any direction for I2 or I3, But after solving, if you choose any wrong direction, the value of the current can be shown as negative value. Then we can correct that our direction which we have assigned is quite wrong. Thank you for watching this video.